Look, see, this is UML 03. In the previous lesson, we talked about the itertools module, and we said that itertools basically provides us with functions that are useful for dealing with iterables, whether we're talking about lists or sets or generators, or perhaps just a particular element that we want to repeat over and over again. And so for that particular situation, we would use the repeat function from the itertools module. And we said we can either import the entire module or we can import 8 particular functions. And we studied these functions and looked at basically an example of how each of them work. But what I wanted to do is I wanted to basically review a few things, and then we want to talk about object-oriented programming before too long, because it's going to be a big new lesson. We said, remember that take while is a generator that accepts a predicate and an iterator, okay? And basically what it does is it's going to yield the elements from the iterator as long as the predicate is true, okay? So what I want you to think about is if you said print list of take while of lambda n such that n is not equal to 2 for tuple of this list. Okay, so this is kind of silly notation, but basically you have to remind yourself that you can always do conversions of data structures, right? And it doesn't really matter how you stack them on top of each other. But obviously this would be a tuple, right, with these 4 elements in it. And so as long as we don't get anything equal to 2, then we should be able to print the values. And that's why when we go ahead and print the list representation of the take while generator, we get those 4 elements. And because we said that we wanted the list representation, okay? And then if we said my tuple equals tuple of 5137, so the same iterator that was brought into the take while generator, we would say, you could say something like it would be equivalent to n equals 0, while n is less than the length of my tuple. If my tuple of n is equal to 2, break, but then otherwise you would just go ahead and append my tuple of n. Okay, so hopefully that makes sense to you. And then you would get the same result for that. That's as a result of printing my result. One of the things I wanted to say is, remember we talked about the count of x generator, and we said that count of x yields all values starting from x and going up to infinity. So count of 12 yields 12 and then 13 and then 14 and 15 and so on. But remember, count of x can accept a negative number too. So what I want to do is I want to show you the result of doing print x to 5 of -2. Remember, we had a very similar function in the previous video, but now we're just going to go ahead and break when we get larger than 5, just so that we're not printing tons and tons of numbers on a tiny console. But then what we can do is we can go ahead and comment out the previous example, and then we can just go ahead and run it. And let's see what the issue is here. So then if we go ahead and say, oh, it doesn't know what my tuple is. If we comment that, well, let's comment out that line, and then we can go ahead and run it. Okay, and then you could go ahead and see -2, -1, 0, 1, 2, 3, 4, 5. Okay. What I also wanted to say is that in the previous lesson, we talked about a generator called accumulate of x, right? Accumulate. Okay, and it yields a running total of the values in x. And we said that's especially well suited to deal with an iterable that just has ints or floats in it. It turns out that you can have a running total of strings. What would that mean? Well, it just means that you're going to keep concatenating a new string onto the existing string. And so I want to show you an example of that. And in fact, you can also have a running total of lists or tuples. Okay, so let's see some examples of that. What we're going to do is we're going to go ahead and scroll down to this. Okay, so remember our function accumulate me of y basically verifies that the accumulate generator that we imported from the itertools module works as it should. And we tried it with these running total of these 4 numbers in the previous video. But then if you do it with these 3 strings, tree, set, and s, indeed it's able to print tree, tree set, and tree set. So hopefully that makes sense to you. And then also concatenating this list onto another list. So 5, it just starts with 5. But then if you have a running total, you're going to add on the 2 and 3. So now you have a list with 5, 2, and 3. That's a list of lists. The same thing would happen if you had a tuple of lists or a list of tuples, okay? And so the same thing happens every time. So hopefully that's clear to you and you can make sense of what's going on there. But it looks like, the returned data type is going to be the inner data type, right? So if a list of tuples, if you called that on accumulate me, it's going to return a tuple, okay? But if you ran a tuple of lists, it would return a running total list, okay? So hopefully that makes sense to you. We're going to talk about object-oriented programming now. So object-oriented programming is when we seek to create our own data type. So essentially, we're familiar with int and float and string and boolean and a couple of data structures. But what if we wanted our program to keep track of person objects, right? What if we had people that we wanted to keep track of the fields and the properties of, right? What if you had a two-dimensional point, like a coordinate in Cartesian space, right? You could have a point object and it would have 2 fields. You would need an x coordinate and a y coordinate. If you wanted to have it in three-dimensional space, maybe you would keep track of three integers for the point, the x coordinate, the y coordinate, and the z coordinate. But basically, we want to get more creative. We want to create blueprints for objects like person objects or car objects, basically extending the functionality and figuring out what types of fields, that is, what variables or properties of a particular object would we want to keep track of, and also what functions should we make available to a particular object, right? A person should be able to eat, a person should be able to speak, okay? And so we can implement that functionality, and we can define what properties, whether their name or their age, and also what functions, going to work or going to sleep or drinking water, we would want to have available to our particular object that we're creating. So this is called object-oriented programming, and we seek to create blueprints for objects in Python, okay? And they can have their own variables and their own important functions, and we get to declare what we think is important and what that functionality is going to be, okay? So we're allowed to define and create that. A class is the definition of an object. The same class can be used to create multiple objects, okay? So if we have multiple person objects, right? If we have multiple people, they all belong to the same class. They all belong to the same person class. But since they're different examples of the class, we would call them different instances, okay? So you should begin to start to get familiar with this terminology, right? Instance is an example, an example object, right, within a class. And then the class is the blueprint, it's the file, it's the skeleton itself. So we're going to talk about that. Okay, and then we also need to talk about a constructor, okay? But let's go ahead and scroll down here and see what we have going on. This is the definition of a person class. So what you're going to do is you're going to write class and then the name of the class, okay? And as a suggestion in Python enhancement proposal, this is written right here in the main.py file, right? We were testing out the itertools generators, and then we just go ahead and declare a class down here. And there's a Python enhancement proposal, so they usually want you to go ahead and have at least two empty lines between the code that you just wrote and where you declare the class. But what we're going to do is we're going to have some class variables. So what we're going to do is these are called class variables. Okay, this is class, and these are just variables that belong to a class. So as long as we're talking about a particular person object, we would be able to refer to that person object's can speak variable. We would want to know if a person can speak, and presumably, we can make a Boolean out of that. Either they can or they cannot. So this is an example of a Boolean variable, a Boolean class variable. Okay, and we would say it's equal to true. But we would say a person object typically cannot fly. So we would set the can fly Boolean equal to false. And then we would set the income of a person object equal to 0, because presumably until they get a job or something, a default person object would have an income of 0. So this is the beginning of a class, and these are called class variables, and you'll see them at the beginning of your class. But you can see that this is a keyword in Python, so you wouldn't call a variable class. It has a special meaning, and basically it's a blueprint for a type of object. So now that we've already created string objects, we've already created list objects, but now we'll be able to create person objects. We'll be able to create tuples of person objects, or dictionaries where the values are person objects. So hopefully that makes sense to you. But these are just class variables, so hopefully that makes sense to you. And then what we're going to do is we're going to talk about a constructor. So a constructor is a sort of a special type of function. I would call it a quasi-function. It's kind of like a function, but it creates a particular instance, okay? It creates a particular example object under the class that we're talking about. So you could create a person object, a particular person object, a particular example, by assigning the object's important variables, their fields, to particular values that the user specifies when he or she is creating the instance. So let me show you what I mean by that. We have a constructor here, okay? So this is basically called a constructor. And it looks like a function, right? So you have def, and then you have this pink word. So normally we're accustomed to having functions appear in yellow, but for constructors, they appear in this pink keyword. And a constructor is basically a function that's responsible for assigning assigning variables that are inherent to an instance of the person class. So assigning, these variables for a particular example to these parameters, okay, which we're going to specify when we create the person object. So we could say something like x equals person of Tom and 12. What would that do? Well, it would go ahead and, say, Python, I want you to keep track of a variable called x. I want you to basically make a person object out of it where the name parameter is assigned to Tom, because that's the first input that I passed in, and the age variable is assigned to whatever I said, 26 or whatever, but that would be the second variable. This self means that this is basically refers to a particular instance of the class. Okay, so self is basically a keyword in person that means that it refers to a particular instance of the class. It refers to a particular person, object, and we're going to be clarifying that in future videos. But basically, I have a little bit of doc strings here, and it's important that you come up with doc strings, not just for regular functions, not just for decorators and generators, not just for inner functions, but also, of course, for constructors. So you would say constructor that creates an instance of the person class by setting the name and age variables for that particular object to whatever parameters n and a are passed in, right? It's kind of like a function. It's like calling a function, right? But you'd have to specify these two parameters. Here you want to ignore self, okay? So basically what you have to understand is that self means that this function or constructor applies to a particular instance of the person class. So hopefully that makes sense to you. So there will be different instances of person objects. For example, you could have a 22-year-old named Pete, right? And in that case, you would say something like A equals person of Pete and 22. So this is an example of an instance, and we're going to see examples of that when we test this out. You could also have a 39-year-old named Tori, okay? And then you could basically say W equals person of Tori and 39. But you can see that the constructor is responsible for giving values to the name and age variables. What are those values? Whatever values were passed in when the constructor was called. Okay, so you don't call init, you just say A equals, give it a variable name, and then equals to the class name, and then whatever parameters in white you need to pass in. Self just means that it applies to a particular instance, and as we look at more functions within this class, hopefully the use of the self keyword will become clearer to you. So that's what's called a constructor. Okay, and we already said that a class can have variables initialized at the top of the class within the class definition. So the class itself has access to these class variables, as well as any instances of the class that were created. Okay, so what you could do is these three variables right here are accessible to the person class in general. Okay, so we're going to talk about what that means, but they would also be accessible to A or W. Okay, so these particular instances. Okay, so if we basically said print of w.canSpeak, it would look at the value of the variable as it applies to this instance. Okay, and so that would just be true. But we're going to be explaining that more. So this is a constructor, and hopefully you're clear with class variables, how to get a class started, and what the function of a constructor is, and sort of what the format of it is. Just come up with important variables, and you'd say name is equal to the first thing that the user passes in, age is equal to the second thing that the user passes in, for example, and self just means that it's for an instance of the class. It's when you're creating an example of the class, an example object, okay? Let's take a look at this function. What we do here is we have a function called work, okay? And then remember, self just means that it applies to a particular instance, okay? So for a particular person object, like a 22-year-old named Tom or a 39-year-old named Tori, we could call the work function on a particular instance, okay? And this is a void method. It doesn't return anything, but it's just a function. And we've studied functions before. The only difference is that this applies to a particular instance. So that's why we write self. It's not an input. It just indicates to Python that we're going to call the work method on an instance of the person class. And we're going to see an example of that. So void method, which prints a work-related string and adds $10,000 to that instance's income value. So what we're going to do, what this function does, if we call it on an instance, it's just going to print a string. That's straightforward enough. And then what we're going to do is we're going to say for that particular instance, for whichever particular person we called work on, whichever particular person, not the general person, but for a particular instance of the person class, whatever we applied the work function to, whoever we applied it to, we're going to increment their value for the income variable to 10,000. Okay, so everyone else's would still say the same. The general income variable of the person class is still 0. Okay, but if Tori goes to work, then Tori's income is not going to be the general person's income anymore. It's going to be 10,000 higher than that. If she works twice, it's going to be 20,000 higher than that. So that's an example of called a void instance method because it applies to a particular instance of the class rather than the general class itself. So hopefully that makes sense to you. And then we can also have get birth year. So this is another function, and this is only a slight difference here. It's also an instance method. Remember, self is not an input. Self means that we're going to call the get birth year function on a particular instance of the class. So I'm going to show you what I mean by that. And we have docstrings, right? So returns the age in which the person object was born, the person instance was born. Okay, and this is a little bit of a simplification, but I just said return 2021 minus self.age. So that means self means that it's referring to the particular instance. Okay, what is the value of the age instance variable for that particular instance? So if you created a 22-year-old named Sam, then self.age, right? If you say x.age, it would be 22, okay? But if you create a person named Tori who's 39, and that variable is y, and you say print y.age, you would get 39. So this is an instance variable, and that means that it can take a different value depending on the instance of the class that you're talking about. Different instances, different person objects will have different values for this age variable, as well as for the income variable, because we said if someone goes to work, then it would increment their income, but not everyone else's income, not the income of a general person object, which is initialized at 0 at the top of the class and kept that way unless there are any functions which change that general variable, but we only have a function which changes the income of a particular instance. So what we're going to do, let's go ahead and test this out. What I'm going to do is I'm going to say x equals person of Sam and 22. So this is calling the constructor, and it's passing in the values in the order that we received them, right? So we say that we want the n and then the a, right? So we say the self.name is equal to the first input, right? And self.age is equal to the second input. Okay, so this creates a person object. The variable to refer to the person object is x. The name of the person object is Sam, and the age of the person object is 22. So let's go ahead and try to print my name is, and then we're going to call the name instance variable on the instance x in particular. So let's go ahead and run it and see what happens. So we go ahead and run it, and indeed it says my name is Sam. So this is an example of object-oriented programming. This person is an example of an object, okay? An object can have fields, it can have variables that are associated with it, as well as functions. So we have two functions here. We have a work function and a get birth year function. So let's go ahead and try to see those two. So what we're going to also do, let's try to print I am, and then we're going to concatenate the age. But remember, when we passed in the age up here, it was an integer, and we said that we cannot concatenate an integer with a string. So you would have to go ahead and convert the integer to a string, and then you could go ahead and figure out how old that particular instance is by calling the age instance variable on that particular object, on that particular instance. So that's why it says I am 22 years old, right? And then if you had a different person object, you could get something different, right? So if you said y equals person of Tom and 32, then you would get something different, right? So you could say something like y.age, and you'd get something different for that result, right? So that makes sense to you, and you get 32, okay? If x.can speak, so this is calling the class variable pertaining to an instance. So we said basically it can take the variable from the person class. So essentially what we have going on here is that name and age are called instance variables. Okay, self.x means that x is an instance variable. Okay, its value depends on the particular instance, the particular example. Okay, but these up here are class variables. So these are general to the class. These are general to the class unless they're general to the class unless they're unless a particular instance changes it for itself. Okay, so we're going to see an example. We're going to call the work method on a particular person, and that particular person's income will go up, but this class variable income will still be 0. Okay, so what we're going to do is we're going to say if x.can speak. So x is a particular instance, and x is going to be able to take the class variable. So we said that person objects have a can speak value of true. Okay, and so that would apply to the particular instance as well. So we're going to be able to print I can speak. Okay, there's also this keyword in Python called pass. And pass can basically, it's a null operation. So it goes into basically an if or a for loop, and it just basically means do nothing. It's kind of a placeholder. And I had that in there just because now I'm going to replace it with an actual print statement. So let's figure out whether or not the Boolean x.can speak is true. And then we also want to figure out whether the Boolean x.can fly is true. So these are examples of class variables, but that means that they can also apply to particular instances. Okay, so now if we go ahead and run it, then we can see I can speak because this Boolean was true, but I cannot fly because this Boolean was false. So that's the introduction to object-oriented programming. We're going to be reviewing these fundamentals in the next video and building on them, but that's the groundwork for going forward. From UMills03, thanks for watching, and please subscribe.